Algebra, Lesson 7-7, Exponential Growth and Decay. Our goal today is to model exponential growth and decay. Here is the formula. Y equals A times B to the X. And today we're going to focus on growth in these first few examples. So that means that B is going to be greater than 1. So that means that on our graph, we are going to be starting small and our number is going to be getting bigger very fast. So exponential growth is a specific type of an exponential function modeled by the function y equals AB to the x, where A has to be greater than 0 and B has to be greater than 1. So that starting value has to be some number greater than 0, and then our growth factor has to be bigger than 1. So if we're given an R value in a word problem, that means we have to do 1 plus the rate and make sure that it's bigger than 100%. So again, exponential growth, our initial amount, the base, which has to be bigger than 1 to the power of some exponent. So which one of these could be growth factors? 85? No. 3? Yes. A half? No. 1.05? Yes. 0.93? No. Because these numbers are less than 1, so they would be no's. Decay factors then would be the ones that we did not circle. Suppose that in 1985 there were 285 cell phone subscribers in a small town. The number of subscribers increased by 75% each year after 1985. How many cell phone subscribers were in the small town in 1994? So we're starting out with y equals A times B to the x. So x is going to be our number of years. Y is going to be the number of phone users. A is the starting number of users. And B is our growth rate. So here's our problem again. Now use the variables, write an exponential growth equation. So we know y. Our initial value is 285 cell phone users. And it is growing, increasing by 0.75 each year. So that's actually our rate. So as a decimal, that's 0.75. So we have to do 1 plus 0.75. So that's going to be 1.75 to the power of x. So that's our function. Step 4, it says use the growth equation to answer the question. So the question is, how many cell phone subscribers were there in 94? So we're going from 85 to 94. So how many years is that? 9. So then we're doing 285 times 1.75 to the power of 9. Throw that on your calculators. Actually try it on your calculators. And I get 43,872 cell phone users. So in those 9 years, the growth grew exponentially. It grew fast. So every year, 75% more people got cell phones. So that turned into 43,872. So 1995 is 10 years, and 2015 is 30 years. So try those. Please pause the video while the students get their calculations. Here are the solutions. In 1995, 76,776. In 2015, 5,571,681,990. Here's the next word problem. Since 2005, the amount of money spent at restaurants in the U.S. has increased about 7% each year. In 2005, about $360 billion was spent at restaurants. If the trend continues, about how much will be spent in restaurants in 2015? So in the word problem, it says it increases 7% each year. That tells us this is exponential growth. So you know this is going to be your model. Figure out what your A and your B are and make your calculation for 2015. Please pause the video. Here is our solution. We get 708.2, but in the word problem, this 360 actually stands for billion, so that would be billion. Compound interest. When a bank pays interest on both the principal, the initial amount, and interest in an account has already earned. This is an example of exponential growth, so putting your money in a bank. So here's the compound interest formula. A equals P times the quantity 1 plus R divided by N to the power of NT. And this is a formula that maybe we should write on the board, but this is something you'll need to know in each class that you take. So A is your balance, P is the principal, the starting amount, R is the interest rate expressed as a decimal, and N is the number of times the interest is compounded per year. So sometimes interest is annual, so that would be where N is 1. Quarterly is 4 times a year. Monthly would be 12. Weekly would be 52. And daily would be 365 times. So T then is going to be the time in years. How many years are you keeping the money in the bank? So let's try a problem that involves this. Suppose that when your friend was born, your friend's parents deposited $2,000 in an account paying 4.5% interest compounded quarterly. What will the account balance be after 18 years? Write down what you know from the formula. What does the phrase compounded quarterly mean and relate to in our formula? So here's what we get. Quarterly means 4 times per year. P means principal. R is your rate. N is the number of times compounding. And T is time. So again, here's your formula, and I think this blue is written on your paper. So let's fill in what we know. So our principal is $2,000. That's how much our parents had. And we're doing 1 plus the rate. And our rate is 4.5%, so I'm putting 0.045. And it's quarterly, so that's divided by 4. So that means 4 times 4, 18 years. So the number of times we're going to compound this for 18 years 4 times, we have to multiply to get that value. So throwing this on the calculator is actually the hardest part of this problem. So here's how I'm going to tell you to do it. I would figure out this value first, and I would have this value figured out. That's why I have this written down. And now this is something that you can easily type into your calculator. Make sure you have the parentheses and you do to the power of 72. So if you invest $2,000 at 4.5% compounded quarterly, you actually get $4,000. Let's try another one like that. Your grandparents opened a savings account for you at birth. They deposited $1,000 in the account and told you you could have access to it and its interest when you turn 18. Your grandparents invested the money at 6% compounded yearly. Find the account balance when you turn 18. So our principal, we're starting out with $1,000. Our interest rate is 0.06 because that's 6%. The time is from birth to 18, and our exponential model, y equals $1,000, and we have to do 1 plus 0.06, so that's 1.06, and we're doing it for 18 years. And we don't have to worry about the N in the formula because we are doing yearly. So then that yearly is a 1 and we don't need it anymore. Because then our formula just turns into 1 plus R to the T. So if we work this on our calculators, you should be getting $2,854.34. Try these next 2 problems on your own. Please pause the video while the students work. Here are the solutions. $574.78. Again, we're compounding yearly. $39,960.19, compounding yearly. So our formula is pretty basic. Try these two problems. Please pause the video while the students work. Here are the solutions. $10,720.77, $2,468.27. Try the next two problems. You have to be careful on these problems because they are compounded quarterly and compounded monthly. If it's annually, it's an easy problem. So here's what you get, 0.04 divided by 4. So you need to find that number and this number before you put them on your calculators. So that's 1.01 for the rate and for 40 periods. Same thing down here on the bottom, 0.028 divided by 12, and then 2 times 12. So then for number 7, you get $744, and for number 8, you get $11,218.